Hello, everyone. If I could get this screen to, there we go. Got it. All right. There we go. Okay, we are going to be talking about the chemistry of life. So let's answer the first question. What is the smallest unit of organization in living things? That is the atom. But first, we're going to be talking about all the matter and everything. So, our first learning target of this lesson is to understand the nature of matter. First, we got to know what is matter. Now, matter is anything that has mass and takes up space. So you can pretty much say everything, but that's not always true, but pretty much everything you know is matter. So in this picture, me, my wife, my 2-year-old that's 4 now. Yeah, so need to change that. Now, there's a law of thermodynamics called the law of conservation of matter. Now, what this law says is that matter cannot be created nor destroyed. And I have this video here that I'm not going to show because you can watch it on your own. It's about a volcano in Italy that is erupting. And the reason I show this video is to show the law of conservation of matter. The mountain doesn't just go away, it spreads out, becomes different states of matter, things like that. Like instead of being a solid, it'll become a liquid or a gas, or it changes from liquid to solid, just stuff like that. So I do use an example. Let me show you. Law of conservation of matter. Here it is. I got a match. Box. I got a match. I light the match. Ooh. And then I let it burn for a minute. Now the matter, it's not just going away, it's burning and it's turning into gases. And you can see oh wait, you probably can't see the smoke because it's smoke on a screen. So that is the law of conservation of matter. And that's pretty much all you need to know about matter for this. Now, our next learning target is show how subatomic particles of atoms are arranged. So we're looking at the different small, really small parts of an atom. So we're going to be looking at protons, which are in the nucleus. That's something you need to know. Protons are in the nucleus, and they have a positive charge. So protons are positive, and they are in the nucleus. Let me get my pen so you can see what I'm doing. Okay, protons are positive, so we're going to say the reds are protons, they're positive. Protons, positive. Okay, electrons, or let's do neutrons first. Neutrons are also in the nucleus, and they have no charge. Neutrons are neutral. Neutrons are neutral. They have no charge. All they are is, I like to say, they're dead weight. They're dead weight in the nucleus. One thing my dad always said to us when we were kids, just messing around, one of his dad's jokes was, if you want to lose 10 pounds of dead weight, you know what you should do? And we're all be like, what? And he'd say, chop off your head. He's such a dork. Anyway, that was my dad for you. Now, here's around in the electron cloud. These are negative. Electrons are negative. So one thing I want to bring up is that atoms need to maintain balance as well. And so they have the same number of protons and electrons, same number of positive charges and negative charges, and so they can stay balanced. Now let's move on to our next thing. Where are we? Yeah. Okay. Elements. Now, what makes elements different? Oh, it's still on the color. There we go. Now, what makes elements different from each other? The only thing that makes an element different from another one is the number of protons. The number of protons makes elements different from each other. So carbon has 6 protons. Well, and it has 6 electrons because you got to balance it out. Let's look at gold. Where's gold? Gold. Well, here's silver. Silver has 47. Now I know that because of the little number in the corner. That is the atomic number. Where's gold? There it is. Gold is 79. That means it has 79 protons, 79 electrons. Okay. Lithium. Here's lithium in your batteries. It has an atomic number 3. That means it has 3 electrons, 3 protons. Sodium, 11. Okay, now let's look at some of the more common elements that we have in our cells. So, since we're going to be moving on to cells, you need to know what types of elements they are made of. And mostly they're made of carbon, hydrogen, nitrogen, and oxygen. So, we look, here are the main 4. Carbon, hydrogen, nitrogen, oxygen. Now I add these 2 right here. I add phosphorus and sulfur just because they are pretty abundant, but they're not as abundant as the first 4. So I use an acronym SHNOPS to help me remember: carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur. So those are the most common elements in cells. Now, if you say that to yourself a few times, you'll probably remember it. That's what I would do. That's what I did to help myself remember. Now, atomic number. We've got to talk about atomic number. I've already mentioned it. Atomic number is the number of protons that are in an element and the number of electrons as well. That's all I really care that you know, is the atomic number. So if, let's say, fluorine has an atomic number of 9, and I asked you how many electrons it has in it, you should know it's 9. That's it. Okay, so anything atomic number is the number 9. 6 for this one, right? 6. All right, so our next learning target is understand basic principles of chemical bonding. So first, let's talk about the electrons and things that there are. All right. So let's say let's just use oxygen here. So oxygen has an atomic number of 8, which means it has 8 protons. So I'm just going to put 8 protons positive. And then I'm going to show the electron configuration. So it has different shells. The first shell always has 2 in electron shells. The next electron shell can hold 8. It can hold 8, but we already have 2 protons here. That means we can only put 6 here. 3, 4, 5, 6. Okay, but it wants 8. So it's going to bond, and here it's going to bond with a hydrogen. Now, hydrogen has an atomic number of 1, so it has 1 proton, 1 electron, and it's going to come in here, and it's going to share its electron with oxygen. Here's another hydrogen, share. Now, hydrogen has 2, because it's going to share 2 electrons, right? Because it wants 2 in its inner shell. So it has 2, just like oxygen has right here. It has 2, and it's happy, so happy. Then oxygen has 8, and now it's really happy. And the reason you have a positive charge over by the hydrogens and a negative charge by the oxygen is because the electrons, which are negative, right? They are going to be around the oxygen more often and longer than they are around the hydrogen atoms. And so you get the slight positive charge because of the 1 proton in here in the nucleus of the hydrogen, and then you get the slight negative charge over here because of the electrons going around there. Okay, so let's move on. Those are valence electrons. They're the outermost electrons. Valence electrons are the outermost electrons. Make sure you know that they are the ones involved in bonding. That's why they're so important. So they're involved in bonding. Now, let's talk about the different types of bonds. Then we have covalent bonds and ionic bonds. Now, covalent bonding is when 2 or more atoms share electrons. They're sharing. I like to say sharing is caring. Remember the C, because the C goes along with the covalent. So, yeah, that's really all there is to it. They're going to share these 2 electrons here, and now it has 8, and that's pretty much it. Now, ionic bonding is a little different. So sodium has 11 electrons. That means it fills up its 2 inner shells, okay? And then it has 1 in its outer shell. It has 1 valence electron. Now it wants 8. So what it's going to do is it's going to loan its electron to a different atom, which gives it a positive charge because it has 10. It has 11 protons here in the nucleus, right? And then it only has 10 electrons. It has 10 electrons and 11 protons, so that means it's going to have a slight positive charge. Whereas chlorine has an atomic number of 17, so it has 17 protons and 17 electrons. But it's going to take that electron or borrow it that it got loaned from sodium. It's going to take that, so now it has 18, so it'll have a slight negative charge, and they're going to be attracted to each other, and you get salt. That's salt. Sodium chloride is salt. So an ionic bond is when opposites attract, or you get electrically charged ions. So an ion is a charged particle, charged atom. Okay. So if you need the vocab word, you need to know what ion means. It's a charged particle. So an ionic bond is when 2 charged particles of opposite charges are attracted to each other and they bond. Now this is a strong bond. If you throw salt in the water, it doesn't just break apart. The water doesn't break it apart. It dissolves in there, but it's not actually breaking the bond. It's not breaking the ionic bond. Okay, that's bonding for you. And that's all I have for atoms and bonding.